You ever notice how a technology, what you see is almost never the whole story? It's kind of like an iceberg, right? You see the clean, simple parts sticking out of the water, that's maybe 10%. But underneath, there's this massive hidden 90% that makes it all work. Well, you know what? The world of programming is the perfect example of this.
Okay, so here's our plan. We're going to start by exploring that entire programming iceberg. Then we're going to gear up for a second dive, this time right into Python itself, to see how this exact same pattern repeats, and, to find out where its real power actually comes from.
So first up, the big one, the global iceberg. That handful of programming languages we always hear about, yeah, they're just the beginning. There is a vast, incredibly diverse world of code hiding just out of sight.
This iceberg metaphor is just a fantastic way to wrap your head around the whole landscape. The languages you see at the top, they're all about convenience. They hide all the messy details so you can build things fast. But as we go deeper, we start to trade that convenience for more and more direct control over the machine itself.
So let's start our descent, shall we? We're going to journey through 5 pretty distinct layers of this global iceberg, starting from the languages everyone knows, right down to the fundamental code that powers, well, absolutely everything.
Right at the top, floating in the sun, we have the most visible layer. These are the languages designed with a super high level of abstraction. That just means they handle all the nitty-gritty, complicated details for you, which makes them perfect for anyone just starting out.
You see this with Scratch, right? It lets kids build entire games just by snapping blocks together, no typing required. It's there in Python's famously clean syntax that almost reads like English. And of course in JavaScript, which brings websites to life without you ever having to think about the bare metal underneath. They're all about getting things done, and getting them done fast.
Okay, let's dip our heads just under the water. We're in the splash zone now. These are still high-level languages, but they tend to be a lot more specialized, doing all the critical behind-the-scenes work.
And this is where you find the real workhorses of the internet and the data world. PHP runs a massive chunk of all the servers out there. SQL, that's the universal language for talking to databases. Bash and PowerShell are the glue that automates system tasks. And languages like R and Julia are absolute titans in the world of statistics and science.
Diving a little deeper now, and things start to get a bit more serious. We find what are called statically typed languages. Think of it like this. It's like having a super strict proofreader that checks your code for certain types of errors before you're even allowed to run the program. And that extra safety net is exactly why they're trusted for huge, important applications.
This is the domain of corporate giants, languages like Java and C#. It's also home to modern powerhouses like Google's Go, which was built for massive systems. And of course, Swift and Kotlin, which power pretty much every app on your iPhone and Android. Down here, performance and reliability are king.
All right, put on your deep sea gear because now we're getting deep. In the middle depths, we're entering the world of system programming. And here the programmer gets direct, hands-on control over the computer's most precious resource, its memory. C is the absolute bedrock here. I mean, operating systems like Linux, they're built with this stuff. C++ takes that raw power and channels it into things like high-performance video game engines. And then there's Rust, the modern contender, which gives you all that speed, but with some really clever safety features that prevent a lot of common and very costly mistakes.
We finally hit the seafloor. Welcome to the abyss. This is the fundamental layer, the direct line of communication between all that software we just talked about and the actual physical hardware of the computer.
Down here, we find the foundation of, well, everything. Assembly is kind of like a human-readable cheat sheet for the processor's own language. But below that is pure machine code, the raw ones and zeros that the CPU actually understands. Every single language we've talked about, no matter how simple or friendly it looks, ultimately gets translated all the way down to this.
So let's pop back up for a quick breath of air and recap that first dive. As you can see, there's a clear trade-off. As you move down the iceberg, you give up some of that ease of use and abstraction, but you gain so much more raw power and direct control over the hardware.
But here's the really cool part. This whole iceberg model, it's kind of like a fractal. It doesn't just apply to the world of programming as a whole, it applies to individual languages too. To see what I mean, let's grab Python from the very tip of that first iceberg, and let's dive again.
On the surface, Python is famous for its beautiful, clean code that's super intuitive. But its real power, its magic, isn't just in that simplicity. It's in the massive hidden depths of powerful tools that are lying just beneath the surface, ready to go.
And to really see what I mean, let's explore these hidden depths by building a little something. A small but genuinely useful tool, a smart folder organizer. And the best part? We can build the whole thing using only the powers that Python gives you right out of the box.
The goal is super simple. Scan a folder, grab file details, count them up by type, and then spit out a nice, clean report. What's so amazing is that Python has this batteries included philosophy. That means its standard library already has all the tools we need: modules to scan directories, tools to count things efficiently, and another one to format that final report. The power is already there, just waiting for us.
And this really gets to the heart of it. People don't just use Python because the syntax is easy. They use it because of the immense power hidden right below the surface. That vast ecosystem of tools is the real reason for the Visible Tip's popularity.
And just how vast is that ecosystem? We're talking about the Python Package Index, or PyPy. It has hundreds of thousands of free community-built packages that can do almost anything you can possibly imagine, all ready to just plug in and supercharge your code.
I mean, you want to build a complex website? Bam! There's Django and Flask. You need to crunch massive data sets or build an AI? You've got NumPy, Pandas, and TensorFlow. Want to automate grab-in stuff from the web? There are tools like Requests and Selenium. Seriously, whatever your goal is, chances are someone has already built a powerful, battle-tested library to help you get there.
So, we've seen this pattern twice now, haven't we? In the huge world of programming languages, and even within a single language like Python, the most interesting, most powerful parts are often hidden just below the surface, just waiting for you to discover them.
The path you take from here, well, that's all about what gets you excited. If that little file organizer tool sounded cool, maybe dive into system automation. If the idea of building websites is calling your name, a framework like Flask is a fantastic next step. And if you're fascinated by data, the Pandas library is basically your gateway to a whole new world.
And that's really the big takeaway, isn't it? The simplicity on the surface is what draws you in. But the true power, and honestly, the real fun, that lies in the depths. So, the only question left is, where will you dive first?